Hi everyone. Today's focus is going to be on Newton's second law in the vertical motion. That's part 3 of the notes. So already we've done Newton's second law in the horizontal motion. The equation for Newton's second law is net force equals ma. So it's the same equation that we're using. We're just looking at vertical forces this time instead of horizontal. So when you look at vertical motion, there's one force that's always going to be there vertically. And hopefully you can guess what that is. This force, weight. The weight of this guy who's rappelling down this cliff would be here. His weight's trying to pull him down to the center of the earth. And that force is always present on any object that's on any planet or moon. So we're always going to be dealing with weight. And we already know how to calculate weight. Mass times the acceleration of gravity. So keep that in mind. And then in this case, the upward force would be tension in that rope that's holding him. So that's Ft. Okay, so the two vertical forces we're looking at in this situation would be tension and weight. All right, let's move on. Get rid of this. All right, so I'm going to use tension as the example throughout this whole part of the notes, but just keep in mind there's other upward forces like the buoyant force. If you have something that's floating in water or air, you might have some kind of fluid. You might have the buoyant force here instead of tension. You could also have air resistance if it's falling through air. But tension is a good example too that we're just going to use the whole time. So here you have this box that's being held by a string, and we can see here that there's an acceleration upward. So in this case, that would mean tension would have to be larger than weight. So in a static state, which means no acceleration, tension would be equal to the weight of the object. So in this case, tension, Ft, is equal to the weight pulling down on this light. So this just means that there's no acceleration. The light could still be moving up or down. It's just not accelerating. It's moving at a constant velocity. Get rid of that. Move on to the next slide. A kinetic state is when there is acceleration, so the object is being lifted or lowered. It's being accelerated up or down. So if it's going up, if it's accelerating upward, then tension is the larger force than weight. If it's accelerating downward, weight is the bigger force. So think about whatever force is winning. Whatever force is winning, that's the direction of the acceleration because there's a net force in that direction. So in either case, if you're going to solve for that acceleration, you use this formula here, which is just Newton's second law rearranged. So the net force would be the tension minus the weight force. And then net force, let's write it out here, equals mass times acceleration. So if you're solving for acceleration, you divide out the mass. And that's all this is here. Acceleration is net force, tension minus weight, divided by mass. So let's try some examples. I think there's one example in here. Couple examples. All right, so a 90 kilogram repeller or climber repels downward from the top of a cliff. If the tension in the rope is 800 newtons, with what acceleration will the climber repel with? So with vertical motion, there's always an extra step of calculating weight. It's not given to us here, but we do know that the force of weight is present, trying to pull this guy down to earth. So we can solve for his weight. We can take 90 kilograms, which is his mass. Sorry, this handwriting is so messy. And then we can multiply it by gravity, which is 9.8. And then we also know that there's a force of tension upward. And that's what we're looking for. Oh, no, actually, we do know that. It's given to us in the problem. 800 newtons is the tension in the rope. All right, so if we do 90 times 9.8, we get that his weight is equal to 882 newtons. Okay, so to calculate for the net force, we subtract tension minus weight. So 800 minus 882 gives us negative 82. So the net force here is negative 82 newtons. And then his acceleration is going to be equal, we know that net force equals ma. So for to find the acceleration, we divide net force divided by mass. So our net force was negative 82 divided by the mass, which is 90, which gives us negative 0.9 meters per second squared. Okay, so we know that he's accelerating downward, which makes sense because his weight is a larger force than tension. All right, I wish there was a way to clear this all in one swoop, but I haven't figured that out yet. So we'll do it this way. Okay, moving on, one more practice problem. A crane lifts a 40 kilogram crate upward with a tension force of 392 newtons. What acceleration will the crate move with? Okay, so again, first thing we want to do is draw out those forces on our object. So the crate is going to have a force of weight, trying to pull it down, and then tension will be opposing. And we know that tension is 392 newtons. Weight we can solve for by taking mass times gravity. So 40 times 9.8, which actually it gives you, I believe, 392 newtons. So we can see here that the net force is going to be 0. So when there's no net force, there's no acceleration. So acceleration will be 0, which doesn't mean that the crate's not moving. It just means that it's not accelerating. Okay, so we could say here that the crate is moving at a constant velocity. It could be a constant velocity of 0, or it could be a constant velocity of any number, okay, moving up or down. So we can't be sure about that. We just know that it's not accelerating. All right, one more practice problem with the crane. Let me erase this. A crane is lifting a 60 kilogram load, there's the mass, by applying a tension force of 700 newtons directed upward. And then we need to solve for the acceleration. So first step, draw the free body diagram. We have a tension force upward of 700 newtons. And we have weight pulling downward. And we need to solve for that weight. We take the mass times gravity. So notice how in every one of these problems, we've had to solve for the weight every time. So 60 times 9.8 gives us 588. So already I can tell the tension force is the larger force. So there's going to be a net force upward. So I should end up with a positive acceleration. So take your 700 and your 588 and solve for the net force. We have a net force, 700 minus 588, of 112 newtons upward. And then when we divide by the mass, net force over mass gives us acceleration. 1.86 repeating. So I'll just round that to 1.9 meters per second squared. Okay, so we did end up with a positive acceleration, which makes sense because we have a bigger upward force. Okay, so key thing here, remember that with vertical motion, you always have to solve for weight and use it to find net force. So there's one more slide here. We're going to save this for next time. We're going to watch some Mythbusters, and this guy, Felix Baumgartner, he jumped out of a weather balloon. Pretty cool story. So we'll look at that on Wednesday.